an executive program for early mid-level managers aspiring to grow into business-critical roles. It's my pleasure to introduce our speaker for today, Mr. Abhideep Chakravarty. Abhideep is an accomplished technology leader with more than 17 years of experience driving business transformation in global organizations. In his previous role as a senior principal architect at LTIMindtree, he played a key role in building high performance engineering teams and establishing centers of excellence. His expertise lies in aligning technology, especially Gen AI powered solutions, with business goals, ensuring innovation and operational excellence go hand in hand. Thank you so much for joining us, sir. Over to you.
Hey, hi, good evening, guys. So I hope I'm audible clearly.
Yes.
Okay, so let's proceed. So I'll take up this session in basically two parts, where in the first part I'll talk about few fundamentals. Mm, Not importantly that you know it or you do not know it, but I believe that these are the things we should be knowing so that we can go deeper with this knowledge. And the second part, I'll talk about some examples and trends in the context of engineering and manufacturing domain. So I'll split my conversation into 20 minutes for the fundamental and 20 minutes for the scenarios. In between, I'll give a gap if you have any doubts in case of the fundamental part. You can ask the questions. I'll try my best to answer them. Post the domain part, again, we'll have a gap. You can shoot your questions at that time. Keep your questions ready. But before getting into the session, as a dipstick test, I have kept 5 questions for you to answer. And this is not a quiz. This is nothing. It is just to understand, how familiar you are with the whole Gen AI thing. And the questions are very simple. There are 4 options. Just select the one you think is right. So I would request Mac to launch the questions for the participants.
Yeah. Yeah, I hope everyone can see it.
Yeah, we can see it. Yeah.
Okay.
Even I can see it.
Okay.
Mehak, I doubt if we can, give the poll answers. There is no bullet that is allowing us to respond to that.
Wait. Okay. Sorry, 1 second.
Should I relaunch the poll? I'll do it from my
Yeah,
end.
but
Yeah,
I
do it.
was poll is not appearing for me.
Okay.
Yeah.
Forum, could you do the AI copy one? Launch that.
Yeah. Okay, now can anybody respond to it?
Yeah, I got it and I am clicking. I'm just submitting my answers. Yeah.
Okay, great. Yeah.
I think you could end the poll. Maybe everyone has.
I have submitted.
Has Shambhavi submitted the poll response?
I think I did submit though.
Okay, yeah.
I have submitted the poll response.
Okay, thank you. So we'll end the.
Yeah.
So do we have the poll results?
Yeah.
Okay. Mm-hmm. Fine. Okay. Okay. Nice. Mm. Okay. So having that out of our way, let's get into it. So let's understand how we will proceed here. The flow of the session would be something like this. We'll talk about the evolution of AI from previous generation to this. We'll talk about predictive versus generative AI. We need to understand this concept because this is where things are little confusing for few of us. Then we'll talk about how these models are built and how they work. Okay, not too deep technically, but at a high level. And then we'll talk about where is GenAI today, and then industry specific scenarios. So this is how the whole flow will go ahead. Okay, so let's talk about the evolution. So there are three parts in it. So this is the first part where we had rule based programming. You would have heard these examples like Java, Node.js, Python, and all those things. These are basically very very specific. You say I need, if you need X, you need to tell that okay, this X needs to be done. If this is the case, then execute that. Okay, so if you look into this screen and if you see all these icons, the first one is flight, second one is hotel, homestays and villas. So this is how it is created, that the first icon will be flight and second icon will be hotels. Okay, this is how it is created. So everything in this screen is uh, either configured to be fixed, or if something is changing, it is configured to be in a dynamic way. But their dynamic nature is also fixed, that this needs to be dynamic. So everything is fixed here. You, whatever you do, you get exactly what you have done, and that is how we have done mostly all the softwares. Okay, you start with whatever you're using, whether it's WhatsApp or Facebook or LinkedIn, or come down to your local usage, Microsoft Office and whatnot. Everything is based on this foundation, on the fixed programming style. Okay, then next is the predictive learning, where where we where we learn from the data. So you use the software, there's a lot of data created, users are doing a lot of things, and with that there's a huge amount of data which got created. And there was a phase in software industry where it was said that data is the king. It is still said data is the king, but this data is actually generated because people started using the softwares, and by their use data is created. Then came this phase where when I have a data, can I put a AI on it and make it learn the data patterns and then predict that what will happen next. If you look into this example, if I'm trying to buy this skull candy headphone, it is, if at the bottom it is saying frequently bought together, this plus the cover, right? This is a recommendation. This recommendation is coming from the data which is being used. Okay, which is like somebody bought this, they also bought this. This is the data somewhere collected, and from that it is learning that when people are buying this, they mostly buy this, and hence it is recommending us to do so. So it is a prediction, a recommendation or the prediction which talks about that you can also do this. Or in some cases, in case of sales and all, what happens is it understands that okay, your this month sale is like this, and your next week sale might be like this based on the historical data. So there's a data required to learn from, and then from that there's a prediction generated. That is what is called predictive intelligence. Then came this generative AI thing. Now you see this photo, this has relevance why I have kept this photo. The core principle here is to generate new content based on the intelligence which has been, received again by looking into a lot of data. Okay. But the key difference is it generates, it does not predict. Prediction is not the key role here. Here, the key role is to generate. It can generate text, it can generate audio, it can generate image, it can generate video, and so on. So if you look into this photo, basically, I have taken a photo of mine from a vacation, and I have given it to Nano Banana and asked him to create a LinkedIn headshot, and that is what it created, right? So it is, if you look into the hands, they don't look like my hands, but it created it based on the data it learned upon. Okay, but he knows that in a LinkedIn headshot, this is how a person looks like. So he put the three-piece suit, a tie, uh, but there's a small part that it also gave a pocket square, which is not required here, but that is the part of his learning. But it is here, this can be considered as a hallucination. We'll talk about hallucination and ethics. Ethics is something which sometimes it misses, something which is not right, it talks about. That happens because it is the part of the generation. But to understand, if you say the basic difference between the previous Gen AI, which previous generation, not the Gen AI, previous generation of AI, which was predictive AI, versus this generation of AI, which is generative AI, the vital difference is one is for prediction and recommendation, another one is for generation. It can generate, it can recommend things in a generative way. It will not just recommend something uh, which you are giving data about. It would have its own knowledge, it can create and innovate on its own, and it will give it to you. So there's a lot of data is there, but the idea is there's a generation versus prediction. So this is one thing which we need to know, and it is important because often when you look into a use case, you need to identify whether this use case is for predictive AI or for generative AI. Generally, people get confused saying that this is a case of AI, hence it is a case of Gen AI. It might not be the case of Gen AI. It might be the case of predictive AI. Okay, so we need to have that very small, borderline understanding so that we don't make a mistake while taking a decision. Okay. Next, as I told you that these generative AI is also backed with the data. So let me explain you how. So I talked about that in the flow that we'll talk about how these models are built and how they work. So for building a generative AI model, which we call as a foundation model, or models you would have heard a lot. We'll talk about them. The first step is to collect huge amount of data. Now, if you look into the left side image, it is saying 10 TB of text. Okay, chunk from internet, 10 TB of internet data has been taken, given it to a hardware which is say 6,000 GPUs running for 12 days, generating bill of $2 million. It's a huge and very costly process to pre-train a model. And then you get a small file, say this is not visible, say 140 GB of file. It's a very small file compared to 10 TB. It's a lossy compression kind of thing, but with a lot of learning. With this data, it learned a lot of things and it understood it and created a file which is around 140 TB in this case. Numbers might vary, hardware will vary. When Llama 3 came, it was 100 million investment from Meta to create Llama 3 model for this process. Okay. The idea is there's a huge amount of data processed for a long period of time, and then it it learns from it and it creates a general information about. And the next step comes where you fine tune the model, fine tune this pre-trained model. So pre-trained model have general idea about the data. In the fine tuning, it's a smaller process, it's less costly process, but it is human controlled process. Here a lot of humans are giving them the input and the output, saying that this is how this question needs to be answered, or for this question this should be the answer, this question this should be the format. So it trains how to respond in a very supervised manner. So this is a supervised learning for the model. And once we are done through this particular process, we get our foundation model. And the foundation model, which you can say chat gpt 4 or Gemini 2.5 or whatsoever you have heard about, right? Nano banana is a small part of it, if you are aware with the latest news. And various models are there. You have cloud sonnet, and um, recently a Chinese thing came up, DeepSeek is another foundation model. So this is how these foundation models are created. The question is next is how it works. So we can, to make it simpler, we can say that they dream and they hallucinate. So to understand how it works is basically at a non-technical level, what it does is it it tries to identify what is the next best word or token. In terms of AI, it is token. But if I say cat sat on a, mostly people will say wall or a mat. That is how it sounds like is the most appropriate next word. Cat sat on a wall or a mat. It might be a sofa also. So that is how the next best word, and then the next best word, and then the next best word. This process is generally termed as dreaming. So because it is generating one thought of out of another, and then next, then next, then next. And that is how when you ask something and you get the whole response. Um, Maybe not today, it is no more like that, but earlier, and not earlier, very earlier, say an year back, it used to come one word at a time on the screen, because it is thinking one word at a time and then it is creating. Now so it is mostly in one shot, but behind the scene it is doing one word at a time. So it does one word at a time and then generates the answer. This is how it works. It is one word after another word in case of text. In case of image, it is one pixel after another pixel. In case of video, it is one frame after another frame. Again, that frame is again one pixel after another pixel. So we need to understand that this is how it works. One thing after another thing, another thing. Whatever is the best match, it takes that best match and attaches it with the pre-existing answer, and that is how it answers your questions. Right? Now, what is hallucination? Hallucination is the part where one of the selection of the next word went wrong. Right? Because it went wrong, the next word, even if fits with the previous word, because it is wrong, it will keep creating the answer which is actually wrong. Okay. So when you ask a question and you suddenly see a wrong answer or you doubt that part of the answer, so for example, I have once asked about uh, ultra wide monitor I had to buy, and I wanted to understand something about the ultra wide monitors. And I asked, and I noticed that when it is talking about ultra wide monitors, it is talking about the resolution in a wrong way. It is taking wrong numbers in the consideration. When I asked that, I don't think this is the right number. The right number is like this. Then it said, yes, it's my mistake and whatnot. But that part of the story was the hallucination. The rest of the things were right, but one part was hallucinated. It went into a wrong path, and then whatever text it generated for that particular topic, it was all wrong. Okay, so sometimes it happens that you get a wrong answer, and that is why it is always said that do not take exactly as is what it is giving. There should be a human in loop. That is how it should be. Okay. So you must be seeing a lot of videos that you can generate a business just by using AI, and you can become a multimillionaire just by using AI. Those are all clickbait, and for YouTube videos it is good, but it's not true. You cannot create a software without having a knowledge in the area of software. You cannot do SEO optimization without having a knowledge in that area, just because AI is there to help you. It will help you, but it will not do the ultimate thing for you. There's knowledge required because there's a hallucination, and that is the reality. To handle the hallucination, you need the knowledge. Otherwise, it looks like it is working, but it might not be working right all the time. In our world, it is said that AI is like a fresher who is very confident even if wrong. So that is how it is. Okay. So let's move to the next part. Evolution of generative AI. This is interesting. I have taken a session an year back, and where we are standing today, there's a lot of changes. So that is why I kept this particular slide talking about the evolution of GenAI itself. An year back, we only had a uh, unimodal LLMs like ChatGPT 3.5. Okay, it had knowledge up to, I think, September 2021. Anything you ask beyond that timeline, it can't answer. Okay, today that is not the case. Today you ask anything, it will answer, because it has now the capability to connect with the internet, do the search and all those things. It was not the case an year back. Okay, or say a year and a half back. um, Then came multimodal. What is multimodal? Multimodal LLMs are when an LLM or a foundation model can understand more than one format of input. What is the format? Format is the text, the files like PDF, Word file, any file you upload, or an image, or the audio or the video. Basically, not only text, it can understand a lot of formats. That is what is called multimodal LLMs. So multimodal LLMs are also not very new. It's few months or around a year old. Okay, prompt engineering was there. It was from the day one. It was there. We'll talk about prompt engineering in a little bit more detailed. And then came RAG. RAG is the capability where you consider it as an open book exam, right? You give a book to a guy and ask a question for which the answer is available in that. What that guy would do is that it will look into that book and give you the right answer. But if you remove the book, he cannot answer that question because he does not have that knowledge, right? Where do you think this thing fits into the industry? For example, if you're working in an organization and you have a leave policy, okay, now your leave policy is fixed to your organization, it is not a public information, right? So being an employee, if you ask, say, ChatGPT, tell me about my leave policy, it will not be able to identify because it does not know which organization you're working for, it does not know what is the leave policy. But if you attach the leave policy document to the model and then you ask your questions regarding the leave policy, it can now answer the questions properly. But this is like you are attaching a PDF and then asking a question, right? If this whole thing is converted into a system, that is what it is called RAG, retrieval augmented generation. What happens is it has the extra knowledge which it is connected to, and then it is able to answer. You don't need to attach anything, basically, because it already has that knowledge by the implementation of the RAG. It has that knowledge. Now you can ask the questions related, which is very private to you or very private to your organization or your system or your setup, whatsoever it is. That is what is RAG. Then came thinking AI. Initial AIs, initial Gen AI around 3.5 or 4, they did not have the capability to think and answer. They were like, you ask a question and I will start dreaming and I'll give you the answer. Then came thinking. It is not a new technology. It is just the reframing the existing technology in a way that it is thinking. Instead of instantly giving the answer, it takes the answer, asks another question on top of it internally. It's not visible to you. And then thinks on it again. It dreams on it, basically, asks another question on top of it, understands the answer, tries to create a strategy around it. And all these things are done via the concept of system prompting. Uh, and it looks like it is thinking because it is made not to give the first answer immediately. It is taking the first answer and sending it back to the system. Now, imagine this. Somebody scolded you. You want to scold him back, right? You want to, but that is your first response, but you hold it. And then you think, instead of this, what should I do? This is what? This you are thinking. That is what it does. It does not give the first response. It takes the first response, and there's a lot of play of system prompting around it, which starts creating the full content which looks like it is thinking. It rephrases the question, it rephrases the answer, it asks cross questions on that answer, and then it generates an answer which is a thought through approach to give an answer. So there's a lot of internal question and answering happening which is not visible to you. Okay. Uh, to you at max, it is visible that what it is thinking, which is a very selective amount of content which is shared with you on the UI. But there's a lot of prompt engineering happening behind the scene. And then nowadays, which came is the agentic AIs and the agents, which is basically an LLM has an capability to perform some action and probably have some memory. That's it. Um, Initially it was you are asking a question, it is giving an answer. And you are asking to create an image, it is creating an image for you. But now it can, instead of just doing what you are asking, it can perform a question, perform an action on your behalf, right? You, if you say that, um, uh, what is the weather in Delhi, it does not know the weather in Delhi, but it'll do a fetch from somewhere, say weather.com. It will go and tell that I want to know the weather in Delhi, and it will take that information and give it to you. So it performed an action on your behalf by going out and asking a question and getting some information and giving it to you. So it can take actions on your behalf. So that is what is the agent. And when you do an AI implementation using agents, that is called agentic AI. Generally people get confused agents and agentic AI. Agents is a component which is intelligence with capability of taking action. And when you do an AI implementation, full-fledged AI implementation using agents, that is what is called agentic AI. Okay, so this is where we are. And about the prompt engineering, I would, before we get into that, if you guys are here and I would like you to do a simple prompt which says that, create a um, write a profile for me, okay, my biodata. You just give that prompt. You will get some answer. Okay, you try it out. Not here maybe, uh, but Then if you do something which is uh, little more detailed question, so in that, when we talk, that is what is called prompting. But in the prompt, there is something called components of a prompt. There are majorly 6 components of the prompt. One is the context, where you give the background of the task. Then you give the task, and then you ask the model to take a persona. Sometimes you give an example also. You can also define a tone and a format. For example, I told you this thing, right? Create a biodata for me, or create a bio profile for me. That can be, it might generate a small paragraph for you. But then you give some context. You say that I'm going to talk in a webinar. Let's take this case. I'm going to talk in a webinar, and I hold this position. I have this experience. Act as a expert copywriter. Give the persona. Then give the task to create the bio for me. In this case, examples are not relevant, but you keep the tone. You say that keep the tone of the content professional. Or if it was, for example, if it was for your radio interview or radio jockey situation, you could have said that keep the tone funny, and give it to me in the format of paragraph, or you give it to me in a format of a poem, or you give it to me in format of an Excel sheet. So you can talk about the format. And when you give all these components, you get a better output. You should probably take a screenshot of this thing and try a prompt, and then start adding these components. And a lot of prompt engineering is actually based on this thing, and various things. And all these things are very important and mandatory part is the task. Without task, nothing happens. You tell everything and then ask nothing to do, it will give something which is of no use. Okay, the task is mandatory. Context is very important. Rest of the things are optional, but more things you add, better output you get, right? uh, okay. LLM hosting, it is like when you are using chat gpt or Gemini, it is publicly available LLMs. If you use an LLM running on your laptop or on your machine, it is called local LLM. You can do it using Olama. Um, Private LLMs, let's say that you are not running it on your laptop, but it is also not available in public. But say you are using Google Cloud or AWS, and you have hosted your own foundation model there, then it is private to you or to your organization, right? So this happens when somebody does not want to use the public thing because data is shared and whatnot. Local is very heavy. You cannot run the local in all the cases. Hence comes the private. So these are the 3 types of LLM hosting which happens. We can talk about it in details later sometime. But for now, I'm done with the first part. So if you guys have any questions, we can look into the questions. Looks like no question. Should we proceed?
Yes.
Okay. So let's talk about how GenAI is being used in manufacturing and engineering domain. Not that the AI is not being used before GenAI. It was used earlier also. There are various forms and shape. Predictive AI was working in manufacturing and engineering domain. So when I'm talking about predictive maintenance, it is the same predictive AI, but when you add Gen AI on top of it, it improves the accuracy, and it creates more scenarios where the failure can happen. Okay, so that is how predictive maintenance is improvised using Gen AI. Similarly, computer vision. computer vision was very difficult, not difficult, but it was not that accurate along with just the predictive AI. But with the generative AI, its accuracy has been increased tremendously. Now by looking into the content, it can easily detect things and say that this is what is going wrong, because its learning pattern is much more improved than the predictive AI's learning pattern. Now, digital twin, most of you might know what is a digital twin. It is basically a digital format of a physical entity. So, for example, if you have a bottle, so this is the bottle, there can be a digital twin for this bottle, a digital format of this bottle where the shape, height, everything is same, and it is considered that the body is of XYZ metal and all those things. Now, when you attach Gen AI with it, uh, then you can talk about scenarios. What if I make it, smaller in size? What will happen? So the impact of this new generation, right, on the digital twin can uh, do a simulation of various scenarios. Digital twins are mostly used for simulations to identify that what will happen if you do XYZ. Now, adding Gen AI on top of it creates more and more scenarios to do simulation, and hence increases the accuracy of the system, or the performance of the system, or the design of the system, right? Similarly, supply chain optimization was also using predictive AI, but with Gen AI, the accuracy has been improved. Now, by looking into it, I can more accurately create the demand forecast that I need XYZ things. Same thing, same concept is applied in the intelligent inventory, or the dynamic routing, or supply analytics. Basically, now, if you think about it from the multi-model AI, multi-model foundation model perspective, that if I have an analytics, or if I have a dynamic routing, if I give that route as an input to a model, and then ask some question that what happens if I do this thing with this data. Till now, it was a data and a prediction. But now I have the data which I can feed to a generative AI model and ask him questions on top of that input. So the possibilities has increased multifold in that case. I can not only say that this is getting over, we can also say that this route might have these challenges based on how many data points you are connecting to it. So from that perspective, the opportunity of simulation and opportunity of prediction has been increased. And as I told, generative AI is not for prediction, but how it is helping, it is generating more and more scenarios to do better predictions. Okay, so it has the capability to generate more scenarios, which might not be the case in the previous scenario. You have only the case of generation which you have the data with, but generative AI can create more scenarios which for which you do not even have the data, right? And then solve the problem accordingly, right? Workforce enablement is something which is, I think, most impacted in the software industry, and people who are linked with the softwares. So if you're using CAD, or if you're using any such tool, what it does is it helps you in doing your thing in a better way, right? uh, the best practices can be implemented without you knowing all the best practices. You can ask the copilot to do those things for you. Similarly, the knowledge industry has been impacted with this, the intelligent training. Now you don't need to have a person who will train, or you will not have to read hundreds of documents, right? I told you about RAG. If you implement RAG here, and if you have a knowledge data which you need to train, using which you want to train your people, so now you don't need to have a physical trainer who knows everything, right? You have the data connected to a Gen AI, kind of a RAG system you have created, and you use that system to train your people. So the system now knows and it learns from that and it has its own information. So no need to run around. Your guys can ask what is this and they will get the answer. So there's a less human required. Again, there's a chance of hallucination, but uh, it solves the problem of training by implementation of RAG. This is the very specific use case of RAG. Okay. Similarly, if you talk about in case of engineering, rapid prototyping, design iteration, material testing, these are the things where you need new and new scenarios to test your case. So it can help you by creating those scenarios for you. Okay, it can generate those scenarios for you um, to do the validation, to understand whether your design is right or not, if there's any kind of best practices to be implemented, because it has that information. If the model is trained, mostly the model is trained on that, it can help you in generating scenarios using which you can test your designs, your implementations, and your prototypes, right? So it is not that it will do things on your behalf, but it will give you support to do your things faster. Where the traditional process used to take longer time, now the same thing can happen in a shorter period because you have the support provided by the GenAI models. So they are giving you that much of information with which you can go ahead and uh, try things faster and get things done faster. That is how it helps. It is not that it is doing everything on your behalf. It is helping you in doing things faster. Eventually it will come out maybe that it will do on your own, on his own, but we do not know. The way AI is improving, there might be a case of that, but human in loop is always important. uh, Hallucinations is the reason for that. The day models stop hallucinating, uh, that would be the case where humans are not required. Okay, so there are few processes where hallucination can be avoided, but we can talk about those things later. Similarly, for the operational excellence, if you talk about knowledge synthesis, RAG, process playbook, again RAG, shift insight, not RAG, but it can summarize. So, for example, if somebody is moving from one shift to another shift, whatever he did, he needs to convey it to the next person. But that is no more required. He can feed the data, and as the data is there, the next person can question on that data, right? And hence it can also be stored for future training and things like that. Continuous training is the case of that. So you not only create the data and synthesize the data using GenAI. And GenAI, I'm not saying that you will feed the data directly into the model. You will do something which is similar to RAG, because building your model is going to be very, very costly, as I told you. The pre-training process is immensely costly. So we don't do that. But in most of the cases, we feed our data to a system and attach a model so that it can respond, which is what is called RAG. So these are all the cases of RAG where we can we can generate our own data and feed it to the system. It goes into the RAG system and becomes a knowledge for that system, so that the next person can ask the question based on that knowledge, right? So these are the cases where GenAI helps by synthesizing the data for various aspects of engineering, right? And there are some industry use cases where people have implemented Tata Steel, Airbus, Bosch, Cell. They have done these implementations, and they have optimized a lot of things in various cases. These are the cases for Tata Steel and Airbus. Airbus is doing it at CAD. They're using CAD, so they are prototyping fast digital twin simulations. um, Tata Steel, if you talk about, they are trying to save more energy by creating more scenarios, that what is the case where if we change X, how much gain we are getting into Y. If we change it by this factor, how much gain there? So those kind of generation and the simulations are helping uh, them to save the energy. But how they are doing it, these scenarios has been fed by GenAI. They are creating those these models are creating those scenarios, and the rest of the things are being handled by the existing system. And with that, they are doing it. So not everybody has done a huge amount of work, but industry is certainly inclined towards and thinking heavily on how to utilize it in a better way, right? So all these examples are where they have implemented it and gained some benefit. uh, Not that these are the world class implementations, but yes, these are the progresses where people are making steps, little improvements, and with that, things will move. So these are probably their pilot programs, and once these things are giving them results, they will move further ahead, right? Now, how do you begin your journey in this case of GenAI? First thing is that you explore and educate yourself. One thing I always say, if you have a question and you do not know the answer, you ask it to the chat GPT. If you have a question, chat GPT or any model you are using, GenAI or Cloud Sonnet, whatever, okay, or DeepSeek, does not matter. I'm not talking about the model. I'm talking about you, how you learn. If you have a question, you ask. If you have a doubt about whether that chat GPT can do it or not do it, ask. You will get the answer. If you have a question about your question, you ask that question to the chat gpt. You tell your doubt to your chat gpt and say what kind of question I should ask. It will give you a question, and then ask that question to the chat gpt. It will give you the answer. So one thing I always say, don't hesitate. Ask the question, put your thought, and let it respond. And then you link it with the prompt engineering. You take care of those 6 parts. You If you talk better with the system, it will respond better. That's it. So you need to explore and educate yourself. Do some pilot, see whether things are working or not. If those things are working, then think of scaling it, and from there the innovation and transformation will come. But first it starts with you. So you need to explore and educate yourself, right? So this is how your journey will start. And in Grow, this is what we are trying to help. We can have such discussions, and all these topics which I have talked about, we'll go deeper into it in further webinars. Uh, at this point in time, if you have any question, please raise.
Hi, this is Harish from Post Marshall.
Okay.
Am I audible?
You are audible, but your voice is little breaking.
1 minute. Am I audible now?
Yes.
So I am from a sector, we are into the energy and brand sales. So we actually deal with direct clients. We study their processes, we identify the energy gaps, and then we build our solutions in that. So how can we use in this manner? So that's what, if you can just throw some light on.
Okay. So the way you solve your problem, right? There are few parts where there is a fixed rule that this is how you go about it. Okay. But then there would be some parts where you you need more input, or you need a system which can understand things better. Those are the places where you can bring in GenAI. You cannot bring GenAI everywhere. Okay. Let me answer it in more clearer words. In your solutioning, if there is a scope where you want to try out the system by simulation, for those simulations you can use GenAI to create more simulation data. That can be one use case. Say you told that you are looking into energy gaps, right? So you want to save the energy of the system. I'm vaguely trying to understand. So what are the scenarios by which that gap needs to be filled? That is one place you can do it. But for example, I'll tell you another example, not exactly yours, but you can relate if something like that happens to you. So if you have something which generates a report, right? Now in the report, you want to you want to understand that report, right? Now what is required for that? A human should read that report to understand that, okay, this is what is happening in this report, right? And this is the input. Maybe this is the first point for you. Okay, a human is required. You cannot give this report to a system and system can read it for you. No, that is not possible. A human is required to do that, right? This is where your GenAI can replace that human. So wherever you need a human to do something, you put a GenAI there. Just try to replace the human in whatever form or shape you have. Like for example, I'll give you another case. So if you have a in one industry, if you have, let's take a very generic thing. If you have a menu, right? You're going to a restaurant. If you have a menu and you want to create a PDF for that menu, it is just some paper. It is written, and you want to create a PDF. So what would be the process? You will read and you will write, correct? So for this reading and writing, you need a human. Instead, you take that image and give it to GenAI and ask it to create a menu in, say, Excel format or a PDF format. It will do, right? What just happened? I just removed a human and put a GenAI there, a multi-model GenAI who can read the image and generate a file, right? So these are the cases in your whole flow where you think you have a dependency on a human. Okay. A human might create more scenarios for you, replace it by GenAI. A human needs to read a report, replace it by GenAI. These are the cases where you can do this thing, right? So you need to think where there's a human required. Those are the most probable scenarios where you can either you do not do it today because it is a human intensive process, or because of that, even if you do it, it is a slow process. That is where you can bring in GenAI. And then one more case is you need to think of RAG, where you need to collect a lot of data and synthesize it. These are mostly two scenarios. One is to replace human, another one is to synthesize some data. Creating a video, creating an image, you would ask someone, right? That if I give you an image, that remove the background, you need someone to remove that background, right? You can ask the GenAI to do it. There are some programmatic way, but I think I'm trying to explain that remove the human and put a GenAI wherever in your process it is required and it calls for it. And if it does not, then if there's a possibility that you can do this and it improves the system, yes. Like I told you, the case of digital twin, which is a very high technology, but when you attach GenAI with it, it improves further, right? Computer vision was doing good, but when you attach this, it improves much better. So those are the cases.
Yeah, got it. Yeah.
Abhideep, can you hear me?
I can. But you're not saying anything.
Can you hear me?
Now I can hear you.
I'm saying I think Harish's question is more like process, more like if can a chat GPT or any generative model, can they do process analysis and identify certain gaps and hence make it easier to find solutions. So I think that is also possible. Harish, I'm just trying
The,
to.
the, the, the question to be asked is, can a human do it? If yes, then GenAI can do it.
Right. So the answer, Harish, is yes, it can be done by a generative model, provided one, the generative model is trained with the data from that industry that you are talking about. If it's, let's say, energy, then energy and utilities. And then when you give a process to it and try to feed data and identify leakage or gaps, etc., it should be able to do it.
Okay, yeah.
Okay. Any more questions anyone has?
Good evening. My name is Ankit, and I want to ask regarding the learning. Say, if I am the person who has never ever, used AI or any generating AI tool, so which is the best tool to start with for, say, my individually my professional career or in my personal life, which could give me a good output, good learning, and also save my data.
Hmm. Okay. In that case, until you said save my data, I was going to answer anything you pick up, Gemini, ChatGPT, anything you pick up. But the moment you said save my data, I
Save or
am
to
thinking.
save my data, to
Basically,
keep my data
you are saying
safe.
that
Right.
your data remains personal; it does not go out.
Yes, yes, yes.
Now there are three solutions to this. One uh, is, as I told you, you do local LLM. Okay, because that works on your laptop, on your device, and you don't even need internet for that because it is running completely on your system. Your data is not going anywhere. That is the best thing. Second thing, you do something which is private, which I told you. You take a AWS cloud or Google cloud kind of service, and you host your own LLM there. Because the problem with the LLM is they need a heavy machine to run on. Your Windows machine might not be capable to run an LLM. Okay.
Okay.
Hence, you would need something like that. Now, because you have personally, privately hosted it for yourself, your data is not going anywhere. The third option is you go for public LLM, but then you purchase the plan. Don't go for the free. If you purchase the plan, there might be an option in the settings which says that don't share your data. You select
Okay.
that. Then your data will not be shared. If you are directly going to public and free, your data might be shared.
Okay. Okay. Thank you.
Any other question?
Okay, I think if no more questions, then I think we could just close the session. So, on, am I audible?
Yes, you are.
Okay, so yeah. So thank you so much, everyone. On behalf of Ahmedabad University and everyone present, I'd like to thank Mr. Chakravarty for sharing his insights and experiences with us. We deeply appreciate your time and contribution. I would also like to thank all the attendees for being a part of this session. Thank you and wishing you all a very good evening ahead.
Thank you, guys.
Thank you.